Hello, everybody. This is August week 4 with the community team, and we're going to show off a couple things this week. First, we got Ryan.
All right. So today I'm just going to show you some improvements we've made to our Parquet integration. I'm going to just first show you the size for a couple of files we're looking at here. So we have two different data sets here. One that is, one large 26 gigabyte Parquet file. It's a little bit interesting in its organization in that it is, 37,000 plus row groups, 13 columns wide.
Can you make that font a little bit bigger? It's pretty
Yeah, absolutely.
small.
There we go.
Beauty.
Oh, now it's off screen. Just give me a second. Is that better?
That's just a little bit better.
Yeah. Keep going.
Yeah.
How about
there
that?
we go. Yeah, that's good.
Beautiful. So as you see, we've got this nice 26 gigabyte file, and as I was saying, it's organized a little interestingly in that it has 37,000 row groups, all of which are made entirely of dictionary pages or dictionary encoded data. And then we also have these other fairly hefty files. It's a 15 gigabyte data set total that we has a similar kind of organizational issue, right? So made a few optimizations to our Parquet implementation. Primarily, the biggest one would be lazy instantiation of dictionaries and lazy caching of dictionaries to go with that. But secondary to that, we also moved caching up a layer to handle the voluminous row group problem. And we also made some improvements to how we're handling file handles in this kind of case so that we don't have, try to use simultaneously 37,000 times 13 of them, right? Or times number of columns in this case, right? So just going to show you a quick demo just to kind of show that, hey, it works. This actually came out of a live example that one of our developer relations engineers came up with. And thank you very much, Amanda, by the way, for finding the problem, because I'm much happier with this. So now we can, for example, actually load this table. So here, let's take the table, and I'm going to just take first we'll just get a handle to it. It's going to do some work. It's going to show us. Usually, this takes about, actually, that was faster than I was expecting. About 6 seconds, I'd say, total. There you go. So you see we've loaded this file. For the improvements, this would never have happened, right? This is our vanilla Docker image, which uses about 4 gigabytes of heap, and with about 4.5 gigabytes of RAM, which is relatively small installation, but it could not handle this particular file at all with the old code. So now I can go look at the tail of it, I can look at the middle of it, I can look at the beginning of it, and we can scroll through this data. I don't know that I can sort it because it's a lot of rows actually, but actually, yeah, no, I probably can't sort it in this much heap, but yeah, you can look at it, right? So that's sort of piece one here, right? And then we have this other data set, which was areas. So I'm going to load that one now for you. And again, this one we actually did do some sorting on. Again, as you can load the whole thing, I can scroll through it. It's a little longer. There we go. But it's a doable thing. Most of the time we're spending nowadays on this data, like that is the time from when I ran that table, that T command to when it showed up was basically just parsing the 37,000 row groups of metadata. So if I take the first 50 million rows of this and sort them, let's say it's going to take, I don't know, between 5 and 15 seconds or so, I think. Depending on how occupied my machine is. But the point is it works. Let's see. There you go. Sorting data. Sorry, I will guess down here. Actually, I'm presenting right now. But that's it. That's what I wanted to show you guys. It works now. All the use cases that Amanda specifically identified work now, and I think all the other ones will work too because the root problem is
Nice. That looked really good. Importing almost 400,000 million rows like very quickly. So.
Well, it's notable that like we don't do work on the order of number of rows. We do work on number of row groups or number of pages. So yeah.
So very cool. Okay, so next up we've got me. I'm going to show off some of the work I did with Markdown notebooks. So this is for a demo. I need to get it a full screen here. Okay, so this is basically a demo notebook that I had together. So as you can see, this is the kind of experience we want to show people when they we're giving them a guided demo. So we have this run selected code button in this tutorial widget. So this is a notebook that I basically just copied some of the tutorial from the doc site. And if you click run select code, it will run that code block and pop down to the next one. So here you go, it creates a new table, and you can just go through the whole notebook like that. The way I created this notebook was just writing it in Markdown. So we're not going to enable this in the demo, but I'm just going to show you that you can edit the notebook to be whatever you want. And like that updates right here. It's all live, and the code blocks are all just contained within the Markdown. So like, so print hello there, and then that code block is now there, and you hit play. And there you go. So that should be useful to give people a guided tour of Deephaven experience. All right, and that is all we've got. So, well, this is the end of the demo. There you go. Cheers.